for a four-digit number, let's call it A, B, C, D, there's four ways I can pick the first number, then three ways for the second, then two ways for the third, one way for the fourth, which is where the 24 comes from. 4 times 3 times 2 times 1. But then what is going to happen is I'm going to be able to write A in the thousands digit in six different ways because it's 24 divided by 4. I'm actually going to write them down. I think I could have B, C, D, B, D, C, or I could put C second, or I could put D second. And I could go with BD or DB, and then BC and CB. But my point is that A will be in the thousands column six times exactly, but B will also be in the thousands column six times, and so will C and so will D. So I am going to get 6,000 lots of A plus B plus C plus D as a result of this. But I can make exactly the same argument for the second column. A is going to be in the second column six times as well. And so is B, and so is D, and so is C. I did that in a strange order, but the result still stands. And so I'm going to get then 600, because remember, I've got every time I add one of them up, I'm going to get 1,000 here, 1,000 here. It's going to be the same in the second column. I'm going to get 100, 100, and so on. So it's going to be 600 lots of A plus B plus C plus D. And the same is going to go for the tens and the units. So what that means is that when we sum all of these numbers together, 24 numbers, we're actually going to get 6,666 lots of A plus B plus C plus D. That's me adding the six times each one is in the thousands, each time it's in the hundreds, and so on. So I want to know the largest prime factor of the sum of the 24 numbers. And it's got to come, well, it could come from here in theory, but the maximum I would get, they're all different, is 6 plus 7 plus 8 plus 9. So we're talking about a number that's less than 30. So let's see if we can get a prime number from here that's bigger than 30, and I don't even need to worry about what that sum is. Okay, and for that, I'll do a little factor tree, I think. So it will be 6 times 1011. Okay, so I've got 2 and 3 down. Now, 11 will go into 1011. If we do a little division, we'll go into it once here, and then 0, and then 1. And actually, 101 is a prime number. So we've got a product of prime factors, essentially 2 times 3 times 11 times 101 times, whatever this ends up being. It's going to depend on A plus B plus C plus D, but we can see the largest prime factor has got to be this one, 101.